not supposed to happen. I apologize for that. Um, let's see. Do I have my pen still? Where's my pen? Oh, there it is. Okay, so what I'm doing right now is practicing some calculus. Okay. Two, and one, -1, -2, and 1, 2, -1, and -2. All right, let's pretend we have this, just open this one up. Let's say, let's see, we have this, and then this. So the limit as x approaches -1 is, oh, that should be an arrow. Okay. What do we want to call this? Let's just call it f of x, because that's the default for everything. So in this case, I'm studying on Khan Academy, so I would say it doesn't exist. So, yeah. Alright, I'm just, running some notes. But if we were to parse it up into two sections, -1 from the right side and limit of x equals -1 from the left side. You can see from the left side, and it's not perfect, but it looks like it approaches, well, -1. I should write function of x on it. But since we established this limit, it looks like it approaches 1. And since these do not coexist, it's going to default to does not exist. Now, for this, let's just default to x approaches 0. Separate this. How's it going, Masita? Thank you for joining. I'm doing great. Thank you, Snowy89. How are you doing, Snowy and Masita? I'm doing great. I want to hear how your days are going. And anyone else who is also joining right now, Root Beer says, #Wi-Fi for Waywolf. What's up, Root Beer? How's your day? Root Beer VR. I'm just doing some calculus. If y'all have any questions y'all want to ask, you can go ahead and ask them right now. Right now, my fella. So we have this. Let's say we have this happening. Unbounded, and also limit as x equals 0 from this side, left side of g of x equals unbounded. So definitely not exist, I think. Yeah, I'm just, working on Khan Academy. If you'd like to stick around, feel free to stick around, but I'm just, doing some calculus, and if you really want to join in, then you can watch some calculus with me. It's a little bit too smart for y'all, but you can try it if you really want to try it. I'm going to college, so yeah, I gotta train. Alright, so this is looking specifically as x approaches 2 from the right side. As positive denotes right side. Negative negative would designate the left side. How's it going, Aditya? It's an HP laptop. HP. What's your favorite, X or Y? This might seem a little biased. If you're talking about math, then I guess Y, because that's the one that I was taught growing up. Y is the function. Although X could be a different function. It could also be a function. They're just letters, but I'll go with Y for now. But if X is better, then that's fine. I don't really mind. So we're gonna look at the right side as x approaches 2. This is x. You could see x approaching 2. This function approaches 1. Okay? So that's false. It needs to approach 3 for it to be true. All right. Now we look at v, and we see the right side as it approaches 2. We're looking at 2, x equals 2. And the right side does approach 3. Not the left side, but the right side does. So therefore, this is true. And C, let's look at this. 2, does it approach 3? 16 people in the chat, by the way. If y'all have any questions, all of you 16 people, ask them right now while I'm at it. Option C is correct. Yep. We look at x approaching 2 from the right side, and yes, it does approach 3. Also true for the left side, but that's not important. And when we check it, hooray. All right. All right, so this video. Ooh, this is gonna be a bit of a challenge, I guess. When I say get a sentence, we're gonna do that by seeing what values for this expression we get as x gets closer to 3. I'm not sure if I could get copyrighted for this, but let's check.
This expression, when x is equal to 3. Well, then it's going to be 3 to the third power minus 3 times 3 squared over 5 times 3 minus 15.
L'Hopital. Yeah. Yeah. I know L'Hopital. And actually, that's what we're going to use later on. So, yeah.
X equals 3.
We're
this
just looking at an
going to be
example
in the numerator
right
of 27 minus 27, 0 over 15 minus 15 over 0.
Yeah.
So this expression is
Hassan,
actually not defined.
Unfortunately, I do not know Arabic, but hello to you, whether it be, how do you say hello in your language? I'm sorry.
At x equals 3. We get this indeterminate form. We get 0 over 0.
Yeah.
But let's see, even though the function, even though the expression is not defined, let's see if we can get a sense of what the limit might be. And to do that, I'm going to set up a table.
Okay.
So let me set up a table here.
Actually,
I'm going to set up 2 tables. So this is x, and this is x to the third minus 3x squared over 5x minus 15.
All right, so you're saying it's 9 over 5. Well, actually, let's use L'Hopital's rule. So, let's use something that I'm just going to use this scrap piece of paper. Ignore the drawings, but All right, let's see. 3x squared and 5x minus 15. L'Hopital's rule. Okay. We down this. In which standard you are now? Right now I'm practicing AB, but I'm going into AC or BC. Wait, what? Is that what you mean, or is something else? What you mean? Uh. Um. I'm not sure if that's what you meant, but BC is the next section. Of course, it's called something else over there. But let's see. Oh, 12th or 11th. Well, what would you consider BC? Well, oh, I'm in college, which is, yeah, I already graduated from high school. All right, sorry about this. We bring this exponent down to the front, and we slash one exponent away from that, and then we get this one minus 9x, and so it's just 1. As x equals or approaches 3. Okay. Okay. Not 9x6. Oh. Thank you for telling me. And this goes away, and we're just left with 5. So we plug in 3, and then 3 times 3 is 9, so 3 times 9 equals 27. 27, and then 6 times 3 equals 18. So 27 minus 18, yeah, it would equal 9. So 9/5 is your answer.
Actually, I'm going to do that again, and I'll tell you why in a second. So this is going to be x, and this is...
I'm not sure if they use L'Hopital's rule in this
x to the
case,
third
but
minus 3x squared over 5x minus 15. The reason why I set up 2 tables, I didn't have to do 2 tables. I could have done it all in 1 table, but hopefully this will make it a little bit more intuitive. What I'm trying to do is on this left table, let's try out x values that get closer and closer to 3 from the left, from values that are less than 3. So for example, we could go to 2.9 and figure out what the expression equals when x is 2.9. But then we could try to get even a little bit closer than that. We could go to 2.99. And then we could go even closer than that. We could go to 2.99.
Okay, so what they're trying to do is they're trying to like approach 3, but not exactly 3. They're trying to get close to 3 from both sides. You're an engineering student in India? Wow. I'm also, I'm studying for electrical engineering. So, yeah. Best of luck for you as well. And, yeah. So, we can skip this video if we wanted to.
So, based on what we're seeing here.
All right. Looks like from the looks of it, it could approach 1.8.
I would.
Yeah. Oh, we got another video. Okay. On Khan Academy, this denotes a video, another video by Aditya. I hope I probably mispronounced your name, but I'm sorry. Thank you so much. Best of luck to you as well, man. We're both engineering. Okay. This is an article. This is an exercise. And this is video, and this is exercise. All right.
The function g is defined over the real numbers. This table gives select value.
All right. It's basically asking what the limit is for this. And see, it tries to approach 5, as we could see here. So we have this table from the left, which is defining x. And then from the right, it's defining g of x. See, this one is 5. Okay. Now, the thing though is they're actually trying to approach 5 in terms of x. And then what are they trying to look for in terms of g of x? Well, that's crazy. Now we can see 3.68 from both sides. Now, make no mistake, whenever you approach 5, if it looks like it suddenly goes up to 6.37, that's just the value, well, actual value, we'll call it, of the function, which can be arbitrarily selected if you wish to. But if you look at how the graph progresses over time, now we don't have a graph here in this case, but if you look at how it progresses, disregard any arbitrary constraints or selections and see if the graph does indeed go to the value, because it can always differ. It could be 6.37, but we're not sure. Yep. This could be this, and this could be that. And while it looks like this is not, this is the real value, but we're looking at the limits, not the real value. Okay. And since it does look from both sides that it's 3.68, it looks like the closest one. All right, let's see. 3 students were given a function of f and asked to estimate limit of x approaching 2 of f of x. Okay. Which is the best one for approximating the limit? Okay, on this one, they're not even trying to approximate anything. They're just trying to, like, increment stuff. And this one, they're just going this, that. They're getting further, and they go to 3. But they're not, like, actually trying to approximate from both sides of the graph. I guess let's go with B. B for, because it does use both sides. Yeah, since it gets closer to x equals 2, which in this case is what we want. As you can see, x equals 2. Hold on. Yep. That's what we're looking for. All right. What's the reasonable limit for 3.68? That's the one we just looked at before. I'm going to say 3.68. Reason being is, when we look at this, 3.37, it looks like a relatively linear increase for both sides. 3.5, okay. 3.68 both sides. It doesn't have to be perfect, but that's what it is. Then we have 6.37, which is, don't get fooled by that. We're looking for limit value, not actual value. Ignore all constraints. Ignore all arbitrations. We're looking at how it is projected to hit. It may not hit it exactly, but it will relatively hit. A student created a table to help them reason about the limit of x as x equals 7. Okay, so based on the table, what can you reasonably conclude about the limit? Okay, we can see already that 7 is undefined. But it doesn't mean that the limit does not exist, it just means that the real value has not been defined there. Or some constraint has caused it to be undefined. Alright, then we go here, 6.99999, 7.0001, that's what we want. And as we look here, it gets close and close and close and close. And it looks like it's going to hit 1.925 if we look closely. Definite. But unfortunately, 7 is undefined, so we cannot see. So based on this table, what can you reasonably conclude about the limit? The value negative 1.925, it's negative, I forgot, is a reasonable estimate if the limit of g of x approaches 7. Yes, it is. The limit does not exist because the function is defined as at x, undefined as x equals 7. That's not what it means. If the limit does not exist, then it's basically like having two different lines or formulas that do not connect at the same location, which is stipulated in here. This is when a limit does not exist, when this does not connect to this because of that. Okay, as we approach s equals 7, the value of g of x ooh, that's a tough one. But we know that it's undefined. There appears to be an asymptote. So let's look at an asymptote. What an asymptote is when one line curves upward and does not hit blah 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 value. So that's not it. It looks reasonably okay. what we want to go. Is it A or is it C? I'm gonna go with A because it is A because 7 is undefined. All right. What is a reasonable limit for the limit of x, or estimate as the limit of x, f of x approaches x approaches 5? What would y'all say? Ooh, 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 ooh. 3.7, 4.3, 4.9, and then for some reason 4.8, 5.6, 6.2, 6.9. It's not 4.8 because if you ignore 5, it looks to be relatively linear in the graph. Well, you cannot see the graph, but if you picture it in your head, it would be relatively linear or something like that. So it cannot be 4.8. That's not our answer. So it would be 5. Depending on what you think, it would be 5.3 or 5.2. I guess it would be 5.3 since that's our option here, and it is 5.3. All right. Hooey. Okay, here we go. Given function h and asked to estimate x equals -8, blah blah blah. Your tables, each table is accurate. We want the one that approaches a single value, kind of like from both ends. This only approaches it from one end, which would be like the right end, right side. This one simply is doesn't really approximate. It approaches from both ends, but not approximate, establishing concrete actual values or something. This one, though, as we can see, 8.0017, 7.999, you want to see from both ends this. Not necessarily exact values, but approaching values. So yes, that would be it. And yeah, that would be great. What is the table okay? No, it does. I can tell you now. When you see 9 as an exact value and its own value postulated there, it is automatically not appropriate because these increments are constant and it's not approximating. Three out of 4. Given the function g and s to estimate limit, which is the best for approximating? I think this one. This one only approximates from one location, and this one from the other, but not both. This one approximates from both. Okay. Function h is defined over the real numbers. It only approaches it from one direction, and you want to approach it from 2. So, yeah, that's it. Alright, what's a reasonable estimate for this thing over here? Okay. Keep in mind, estimate, not this is what it is. Because that's not what we're trying to study. Alright, reasonable estimate as x approaches 0. Oh man. From this side, from the left, it looks like it approaches -5, but from the right, it looks like it approaches -3. So I would say the limit does not exist, and there's no specifying. It specifies the whole limit, not the left limit or the right limit. So we're gonna say no, not exist. All right, I'm just gonna look at something right here. All right. Ooh. It does not. It does not. Hold on. All right, we're back. We've got 2.3. And as you can see, it looks like from both sides it approaches. It looks like almost 10, so I would say 10. Okay. All right. Oh, frick. All right. All right. From the right side, it looks like it is approaching to. No, 4.2. Sorry. And from the right, it looks like it's approaching 0. So, or no, sorry, that's a mistake of mine. 5.99. That's close to 4.2. No, it's a. Sorry. 5 from this one is 4.9. So we would think it would be 4.17, and then increase back. So yes, 4.17 is correct. And I'm gonna just finish up this unit and lesson and finish it up. What is a reasonable estimate for this? Ooh. $9.2. Looks like it's decreasing. That's a tough one, I guess. But let's see. It would decrease. But from this side, it's increasing. This approach is 9, but this approach is 8, so I think it's not existent. But I could be wrong. No, I'm not. Alright.
The function f is defined over the real numbers.
I'm back. Oh, well, never mind. Alright, I've returned back to this.
Select values of f. We have our table here for these x
Okay, sorry about that. We had to mute it because my mom's here. So this is the left side. So we look at this part of the graph, not this one. No, this part stipulated here. This is the value which is not going to be approximated. And you can see it's not continuous. We're just, since both do not coexist, this would be 2. This would be -1 on the right side. Oh, Hassan is back. X squared plus y cubed root of x squared, all of that squared, equals 1. Wow. Let's see. How would we specify y though? Alright, we'll start. Okay, let's try it. You've got my attention, you guys. Plus y so immediately we would subtract 1 from that. So that would be this. So how do we get that out of here? So x squared, and subtract this whole thing with the y. X squared, squared. I think that's good. X squared plus. Oh, sorry. No. That's not. Sorry. And we gotta get this negative. Oh, shit. This is not happening. This is not happening. Hmm. 5. What if we do this groove? So that would be negative x squared plus 1. Let's get this. Okay, now we can try it. So then we could subtract or get this to the other side, and okay. Okay. I'll get to that later. Maybe not, but I have to get. Right now, I'm going to concentrate on this. Function f is. Yep. And we go here. This is 205, 201. So it's approaching -2, as we can see here. 25, 500. So like 1,000 perhaps? Oh, unbounded. Wow. I'm just gonna try one more exercise and let's go. What's this estimate for this? Limit of enter this equation in engineering calculator. All right. Well, let's do this. Well, x squared plus y it sounds familiar, but something like this. Is it like half a circle or something? And I'll look at the coordinates. Oh, that's a heart. Yeah. Aw, thank you so much for that. And I'll look at the coordinate. Well, actually, the graph has everything I needed to know. So that's what it was. Thank you. Thank you so much, Hassan. Alright, that's unbounded. We've got. Okay. Got that. From the right side, it's approaching 2. From the left, it's approaching -1. 7 plus, so that's the right side. I'll get to Instagram in a moment. Okay, it doesn't look like it's bounded. Okay, then for -4 on the right side, the positive side. This is what we're looking for. So it looks like it approaches 6, -6. All right, quick break, and then we're going to go for our quiz. Okay. Awesome. You improve your skills. Quiz 1. 6 questions, 6 to 12 minutes. Alright. Looking at -4. I think it's unbounded. -4 on the right side. It's unbounded from both sides. I might get this wrong, but you're almost there. Choose the correct number of answers. Give it another try. Oh! Okay. I didn't even see that. I think this could be correct. 4 from the left side. 4 approaches 3. Is that correct? Yes. Function g is defined for all real numbers except for x equals 5, which approaches -2. Okay, function g over real numbers except that x equals 2. This unit gives select values of g, which is a reasonable estimate for the right side. 7. Alright, I think there's 4. Ooh, -1. 3.3 sounds correct. Ooh. Oh yeah, I think it's negative. Or sorry, 3.3. Yep. This. Okay, looks like it approaches 12. Okay, last question. It must approach from both directions. This is what we want. Not, well, this one is part of it. This one just doesn't approximate. Like it goes from both directions, but not approximating. Let's go with B, final answer, yes. That's great. All right, guys. Well, thank you, Aditya and Hassan for joining, and Masita, Snowy, and Root Beer VR. Thank you for that, Hassan, for that heart. I really love that. It made my day. And I hope all of y'all had an amazing day, my friends. I'm gonna study some more calculus later, but I'm just gonna be offline for now. But thank you so much for watching. I'll join y'all one of these days again. And yeah, let's see what happens. Peace.